What do automated trains, rehabilitation, and remittance all have in common? Space data. It's transforming our world. Incredible projects in these domains are happening around Europe and beyond, thanks to the power of satellite data. SatFin Africa has created reliable, secure financial solutions for millions of isolated people in Africa and around the world, while also generating domestic employment. Geosatis have designed an ankle bracelet that utilizes satellite navigation to provide a secure solution. Their management and supervision of offenders throughout the rehabilitation process offers a more humane and cost-effective commercial alternative to imprisonment. Then there's the world's first fully automated long-haul cargo train, now running in Australia, using satellite control systems designed by Italian company Ansaldo STS. And there's plenty more out there. All these projects are possible thanks to the power of space data and the support of ESA business applications. We've invested over 200 million euros in more than 500 European businesses, created 2,500 new jobs, and enabled 130 million euros of external investment. Thanks to the contributions from our national delegations and private investors, we provided a 4 times return on investment, with a long-term projection of over 7 times. Our initiative has stimulated the creation of an entirely new space investor ecosystem. To discover more about our program, visit business.esa.int.
The global demand for secure satellite communication services is strongly increasing. It's driven by many areas such as border control, maritime surveillance, and further crisis management. We expect the market to grow from around 4.6 billion in 2020 to 6.5 billion in 2025. This is clearly creating significant business opportunity for the European industry.
ESA's GovSatcom Precursor Programme is laying the groundwork in line with the EC's space strategy for Europe. Partnering with ESA member states, European operators, the EC and the EDA, it is developing innovative. The European Data Relay System serves the EU's Copernicus programme via gigabit optical links, providing terabytes of encrypted data from space every day in support to quasi-real-time Earth observation services. However, Europe needs to advance its capabilities in secure SATCOM by ensuring the evolution of these developments and addressing the full life cycle from R&D to new operational services. This will help Europe become a front-runner in areas such as optical communication, quantum key distribution, services to the Arctic, and could facilitate a European LEO constellation. We must support both national and Europe-wide initiatives to meet the future demand for safety and security services on commercial and governmental systems.
Action is now critical to enable Europe to fully benefit from the market potential offered by secure communications. Just to give a few numbers, we expect total demand of capacity to grow by a factor of 30 by 2040. On this, civil use of government satellite communication capacity should more than double and represent more than 70% of future demand.
ESA is proposing a comprehensive program to deliver SATCOM solutions for a wide range of safety and security applications. Undertaken in partnership with industry and aiming to include EU institutions as anchor customers, the resulting ESA-managed R&D and innovation could also benefit the EU's GovSatcom. This will enable a timely implementation of world-class services to meet increasing European and global demand.
Turn right heading 180 degrees.
The face of air travel is changing in ways that are going to affect us all. As our skies become increasingly busy, how they are managed also needs to evolve. IRIS is a next-generation service developed and deployed as part of the EC's SESAR Single European Sky ATM research. New forms of air travel are all connected, and Europe is leading the charge in introducing satellite capabilities as an enabling solution. Aircraft flying over land currently communicate with air traffic control via ground-based data links such as radar and radio channels, which will reach capacity by 2030. IRIS technology will help relieve pressure on these channels by sending vital aircraft information and safety services through satellites. Instead of voice, improving speed and accuracy. The IRIS SATCOM-enabled services will also be able to pinpoint aircraft in space and time, allowing air traffic management to calculate the safest, most efficient flight plans, resulting in greater availability of flights with fewer delays and lower CO2 emissions. Modernisations like these are crucial, as the number of flights over Europe alone is expected to grow by 50% over the next 20 years, which current systems will not be able to cover. Ever-increasing range of users, IRIS will provide an essential part of the digital communications infrastructure that's necessary to ensure that it does so safely, efficiently, and to the benefit of us all.
Today, everything is connected. Connectivity underpins the world around us. Traffic, energy, and partners. Secure communication requires cryptographic keys shared by two partners. Anybody else in possession of the key can decrypt the message and gain access to the secret content. Generating and sharing these cryptographic keys is the foundation of secure communication. Depending on the circumstances, secret keys can be shared by trusted couriers or mathematical algorithms running on computers. Quantum key distribution is a new disturb the particles, producing a broken key that the users can detect and discard. The challenge of quantum key distribution is how to deliver all the keys to the many users distributed over Europe and the world. Photon signals degrade over terrestrial fiber networks, requiring new sets of keys every 150 kilometers, which drives up system costs and can create additional vulnerabilities. A space-based service can reliably and cost-effectively connect a multitude of diverse users over large distances, complementing a terrestrial approach to cover smaller distances. In space, quantum photon pairs are generated by a satellite. Two laser terminals direct the photon pairs to optical ground antennas deployed at the secured user sites where the photons are used to generate keys. The laws of quantum physics dictate that the keys are never present on board the satellite. Positioning the satellite in a geostationary orbit allows full coverage of Europe and the surrounding parts of the globe. It also means that when there's cloud coverage, the key delivery can be rescheduled to cope. The European Space Agency plans to develop a precursor to such a quantum key distribution network, the SAGA Security and Cryptographic Mission, which will develop and demonstrate the optical laser terminals that can send and receive quantum photon pairs. The SAGA method allows security certification to stay with each ground user, who only needs to trust their own ground station and network, paying no mind to the satellite or partner elements. The European Commission is currently exploring the use of terrestrial fiber communication networks for generating and exchanging keys using quantum technologies compatible with SAGA. This terrestrial quantum infrastructure will help enable the EU to securely exchange sensitive information across the member states. ESA and the European Commission have entered into an agreement to explore the design of an integrated quantum communication infrastructure, including both the terrestrial and satellite components. SAGA will enhance quantum key distribution to meet even the most demanding users' needs, providing a new and more flexible way of protecting communications, both within Europe and beyond.